In our last video, we added together two negative decimals. Now we're going to work some examples of when one decimal number is a positive and when one is a negative. And the good news is that it's really exactly the same thing as doing it with whole numbers or integers. So if I did -3 plus a +2, I'm just doing a really easy one. So I've put my -3 out here in my chip model, plus a +2. We all know what happens when a positive and a negative get together. Poof, they disappear. Poof, they disappear. So now I'm left with a -1. My answer is a negative because I had more negatives than I did positives, so that when they got together and canceled out, I was left with negatives left over. Well, lucky for us, decimals work exactly the same way. So we're going to look at a couple of examples of that. Let me get my decimal number up here. Alrighty, so let's say, well, first of all, I better remind you of what the decimal place value is. We've been working with this for a while, so hopefully we know. So the blue, the gigantic cube, represents units. And the fact that it's blue represents a positive. The red ones represent a negative. And just like our positive and negative chips, if you put a positive on top of a positive one on top of a negative one, poof, it cancels and it disappears. My next place value is the tenths place. So if I pull a positive tenth and a negative tenth down here, drag one on top of the other, poof, it disappears. My next place value is, of course, the hundredths, and then I have the thousands. And you get same thing as all of them. A positive hundredth and a negative hundredth will cancel each other out. So let's see how that works with an actual decimal problem. So the first one we're going to work is a positive 1.635, and I'm going to add that to a negative 0.421. So I'm going to make a model of the positive part first. So this is a +1. I'm not going to spend too much time on the place value. We've been doing this a lot now, so hopefully you remember how it goes. And 6/10. Oh, oops. It would help if I put a positive up there instead of the negative here. He doesn't want to go away. There we go. So this is a +6. So 1, 2, 3, 4, 5, 6/10. And 300ths, 1, 2, 3, and 5 thousandths, 1, 2, 3, 4, 5. So now I need to add to that this negative number. So I don't have any negative units, but I do have -4/10. So I'm going to put 1, 2, 3, 4. Then I have -200ths, -2, and -1 thousandths. So now I can kind of start doing a little bit of canceling here. This positive and negative thousandth are going to cancel and go poof, cancel, poof. This positive and this negative will poof, or I like poofing in case you can't tell. I'm going to cancel out. Let's see what we've got left over now, shall we? So we've got 4 thousandths, we've got 1 hundredth, we've got 2 tenths, and we've got 1 unit, which, oh my goodness, is exactly the same thing if instead of adding these two numbers, this positive plus this negative, we just subtracted. 5 minus 1 is 4. We had 3, we canceled out 2, so it's going to be a 1. We had 6, we canceled out 4, so now it's a 2. We had 1, we canceled out none. And of course, we had a lot more positives to start with than we did negatives. So once I used these 4 tenths to cancel out 4 of those tenths, I still had 2 positives left over. Once I used these 2 hundredths to cancel out these 3 hundredths, I still had 1 positive left over. Once I canceled this 1 thousandth, I still had 5 thousandths left over, or 4 thousandths left over. So my answer is a 1.214. So just like when you're dealing with whole numbers, -8 plus +3. Okay, 3 of these negatives cancel, or 3 of these 3 positives cancel out 3 of those negatives. So 8 minus 3 tells us we're going to have 5 left over. When you're adding together numbers that are a different sign, you're really subtracting whichever one you have more of minus the one you have less of. So because I had more negatives in this case, I turned out to be a negative. In the case of my decimal example here, I started out with more positives than I did negatives. So once I did some canceling, all this canceled, and I had 1.214 left over. So the rule is if they're a different sign, just like our song from our integer rules. In the last video, if they were the same sign, you would just add it and keep it, but they're a different sign, so you're going to subtract. Let's work another one, shall we? Just to make sure. It might be a good idea for you to pause the video, take just a moment to try the next one on your own, see if you can figure it out, and then check your answer with me in just a moment once you're done. But the problem is negative 5.621, and I'm going to add a positive 2.301. So you might want to take just a second. Okay, they're not the same sign, so you're not going to just add them together. Keep that in mind. I'm going to go ahead and make a model. You might want to pause the video for a second. So I need negative 5, 2, 3, 4, 5. I need a negative 6 tenths, 1, 2, 3, 4, 5, 6. I need negative 2 hundredths, 1, 2, and negative 1 thousandths. Then I need a positive 2. I need a positive 3. I need nothing. And I need 1 thousandth. I need a positive 1. So now let's start canceling. So really I've got one negative here and one positive here. So when they get together, they're going to poof, cancel. That's going to leave me with nothing. 1 minus 1 is nothing. Here I've got two negatives that are going to, don't have any positives to cancel with, so they're going to stay put. So 2 minus nothing is 2, because none of these hundredths got canceled because I didn't have anything to cancel it with. So now I'm going to start canceling here. So poof, and poof, and poof. So I've got 1, 2, 3 left over, which makes sense because I had 6 negative tenths. Then I put it together with 3 positives. When that canceled, I was left over with 3. Now I've got a positive 2 and a negative 5 that need to go together. Yep, you guessed it. Poof and poof. So now I'm left with 3 negatives. So there you have it. And you get the same answer as if you had subtracted. I had 1 thousandth. I took that positive 1, canceled out the negative 1, so I was left with 0. My negative 2 combined with nothing, so I still had a negative 2. My negative 6 tenths combined with positive 3, which left me with a positive 3. And my negative 5 combined with my positive 2, which left me with a negative 3 left over after it canceled. So when you are subtracting, or when you're adding decimal numbers that have a different sign, what you're really doing is subtracting, because you've got this many negatives, you put together this many positives, and these are going to cancel some of your negatives, but you're still going to have some negatives left over. So let's try them without the chips now. Just a couple to make sure that we are all on the same page. And so let's do a negative 6. Oh, why aren't you working? There we go. Negative. Why aren't you wanting to work for me? Well, well, that's bizarre. Okay, well, I guess I'm going to go back here to where I can write. So this is a little bit awkward. All right, so I'm going to add a negative 4.7 plus 3.6. And that's a positive 3.6. So figure out, first of all, which one you have more of. We've got more negatives than we do positives. So that means we're going to have negatives left over. So we need to take our negatives and subtract our positives. So 7/10 minus 6/10 is 1/10. 4/10 minus 3/10 is a 1/10. Because we had more negatives, that's going to be a negative 1.1 left over. And let's see, yeah, it's just not going to work for me. So I guess I will not be able to show you anymore. But actually, pause, hang on 1 second here, because yeah, we should definitely be able to, let's see. Yeah, go ahead and stop the video. I'll do another one where I work in a few more examples for you in just a minute.